Stanford University.
All right, let's get started. So lecture 13, today we're going to talk about some more concepts, some of the stuff you need for Presence 3. First I'm going to start off with some debugging tips. We'll talk about searching, how to search through your app, notifications, so how to get notified when things change, and then something called KeyValue Observing and KeyValue Coding. So before we get started, announcements. First thing first is this Friday, Jessica Kahn's going to be here from Tapulous. I believe they're also looking for people. So if you're looking for an internship, go check them out. But they're going to talk about their experience developing apps, and they have several very popular ones, including TapTap Revolution and several others, actually. OK, Presence 3 was due last night at midnight. So if you're not sure how many late days you still have left, come talk to Troy at the end of class, or send us an email, and we can get you that information. And Presence 4 is out today. So this is due next Tuesday at midnight, so please take a look, get started. This will be the last announcement, the last assignment. After this, it's final project only. And the next few weeks, so the last few things we're going to talk about, again, your final project's due on the 7th, which is the Sunday of June. I'm all over the place today. And so what we're going to be talking about before the course is over, multi-touch, device APIs such as accelerometer and location, some audio, video, and web views, so how to add media to your application, and then some other stuff. Evan's going to talk about the nitty-gritty stuff that he alluded to last week. So in today's topics, once again, so exceptions, I want to show you how to catch things. Many of you have ran into some problems in your assignments, so I'm going to show you some little tips. Searching, notifications, KeyValue Coding and Observing, and give you a little demo of Presence 4. So let's get started with exceptions. The first thing I want to talk about is you may be familiar with the concept of exceptions from other languages, Java, C++, where you, when you get an error, you throw and you catch the exception, and you can handle it in some way. The convention in Objective-C is less about using exceptions as a means, as a branching mechanism, and more about really handling cases that are problems in your application. So if you have bad data, or if you have something that, as a programmer, you were not expecting to happen, that's the perfect case for an exception. And when actually running, whether it's on device or in the simulator, an exception will crash the application if it's not handled properly. So I'll show you how to catch those and then how to deal with them. Some examples of what would raise an exception. If you try to access an array past the end of the array, so if you have 10 objects in an array and you ask for object number 11 or object at index number 10, you're actually going to get an exception crash. If you try to call a method on an object that is not implemented, and it could be just because you spelled it wrong, you're going to crash. You're going to catch an exception, I should say. And if you try to get or set a key on an object that doesn't exist, that's undefined, then you'll get an exception as well. And I'll talk about at the end of the day how to override that behavior. So the first thing is debugging exceptions, and this is kind of a pain in the butt when you run into it, because what happens is when you catch an exception, the stack trace really doesn't tell you very much. You fall into this Objective-C exception throw function. And if you were to look back at the rest of your stack trace, it doesn't show you where it happened. There's often some good documentation in the console that tells you what happened. In this case, we went off the end of an array, and it tells you specifically, object at index 5 is beyond the bounds of 0. The array has no objects. So this is usually a good place to start. But again, it doesn't tell you exactly where you should look. So there's a way that you can do that. There's a way you can catch this. If you put a breakpoint in Objective-C exception throw, you will actually catch the exception at the point where it's thrown, and you'll see a stack trace that reflects where the problem lies. And I'm going to give you a demo of this. But again, the console output is usually enough to give you an idea of what's happening, but to locate it, this is really what you want to do. So let me give you an example of that. So I have let's create a new project here. So window-based application. I'm just going to call it exceptional. So right where the app loads, Let's make this full screen. Right where the app loads, I'm going to create an array, put an object in it, and then try to access something off the end. So let's see. Let's create a NS string first object, and we'll say this is my first object. Now I'm going to create an array. And I'm not going to put any objects in it. But the first thing I'm going to do is I'm going to log the first object in my empty array. So first object is array object at index 0. Let me check something here. Actually, let's just give this a run. So if I run this in the debugger, so build and debug, what we see is interrupted. So if we go into our debugger and we take a look, we threw an exception, terminating due to uncaught exception. And if we look at our console, what does it say down here? Object at index 0 beyond bounds of 0. But again, it doesn't show us where it is, right? I mean, we know where it is because we only have 3 lines of code in the app. But let's say you have thousands and thousands of lines of code in your app. There's a better way to catch it. In Xcode, you actually have the ability to add breakpoints using a command line kind of interface. Or actually, there's even a better interface for that. If I go into, where is that? If I make this bigger, there's a little breakpoints window that I can pull up. And I can add a custom breakpoint. So let's go, sorry, I'm going to type in here the, I don't know if there's a better way to remember this, but the language is Objective-C, and we're throwing an exception, so it's exception throw with underscores in between them. And I just added a breakpoint at the top of that function. It's not our function, it's a system function. But now whenever Objective-C exception throw gets called, we have a breakpoint set. So let's give this a try. I'm going to build and debug. And here we are. So we have the same exception. We're actually in Objective-C exception throw. But if we look down at our stack trace, it actually shows us some useful information. If we go down the list, we see that exception was raised. It's an array bound raise exception in the object at index call. And then here's our function, which is where we actually try to get the first object of our empty array. So the easy fix here is I should have actually put the object in there. First object. We give it a run, and we should be happy. Oh, there's nothing to display, but at least we didn't crash, right? So that's exception handling. Any questions on this? People have hit this in their assignments, right? Yeah?
Oh, OK. So does this it automatically adds a nil like we don't have to? Oh, sorry. Because usually does it crash when you don't have to?
Oh, there's another function called. You're talking about when I created this array here? Yeah, there's another function called array with objects, and that one expects the null terminator. Yeah, and there's actually the init version of this. So you can say init with objects. There's no init with object singular. So you may have seen that as well. Any other questions about exceptions? No. OK. So let's move on. So let's talk about searching. Searching is actually something you do fairly manually in your application, but there are UI elements that will help you present UI to the user to make searching easier. So searching obviously helps your users search through a large amount of data. If you have several, if you take your Presence 4 assignment, you have hundreds and hundreds of users, and you want to find one quickly, it may be quicker to type in the name than it is to go through the alphabetical list. So searching will give you an advantage there. You can search local data or remote data. So if the data is local, you obviously do the search. Well, in both cases, you do the search in your application. But in one case, you may want to dispatch a search off to a server and let that do it and return you the results. Consider the performance when you decide what you want to do. So if you have a server that provides searching capabilities, but your app is only looking at a few pieces of data at a time, maybe searching is better to do locally. And of course, for SQLite, if those of you that use SQLite, there are some searching APIs in there that should help you as well. Now, the UI that's available to you is UI search bar, which is actually very much like a text field. It's formatted a little differently. It's got rounded corners, rounded edges, so all the search bars, all the UI search bars on the phone look the same, so people know kind of a visual cue that this is for searching. There's even a little magnifying glass in the corner. There's provisioning for bookmarks. That's all built into this UI search bar. And there's specialized delegate routines that will help you get notified when people click on things. So again, it's often at the top of the screen. Sometimes it's right in the navigation bar. Sometimes it's used as a table header. I'm going to show you how to use it as a table header. And it adopts the text input traits that we talked about a couple lectures ago. So you can say autocorrection on, you can say auto capitalization, stuff like that. And the keyboard that is associated with this automatically gets the search button down in the bottom right corner. And then, of course, as I was talking about, we've got the the bookmark button and the cancel button are options on your UI search bar that you can enable or disable. And the delegate callbacks, there are delegate callbacks for each. So you can get a delegate callback when the bookmark button is pushed, and you get another one when the cancel button is pushed. So let me show you how to do searching. And I believe this is this in Presence 4?
It's part of that.
Yeah, part of Presence 4, so pay close attention. All right, so let's go take a look. All right, so let me give this a run first and see where we're at. All right, so here's our application. You'll notice that I've got a search bar in my table. It scrolls with the table, and there's a bunch of data. When I type, I could type a couple of letters, and then when I hit return, it actually filters those pieces of data. So let me go into the code and show you how that works. Let's clear that out. All right, so let's look at the nib first. Is there anything interesting in that nib? Actually, I believe this is all in code. One sec. All right, so that creates a table view. Where the heck is that? Table header. Sorry, it's right at the top. OK, so in my view did load. Well, first let's look at here where we create the data. So right when I start off, we've got a big array of names. All right, names include all the profs in your class and Pee-wee, Herman. When the view gets loaded, this is a table view controller. So what we do is we create a new search bar, and we size it to fit, just like with text views. We want to size it to fit so that it automatically takes the width, but fixes the height to be the proper height for search bars. And we set that to be our table's table header view. And what that does is it puts it at the top of the table, and it's not part of your list. Right? So that's why I was able to get that scrolling behavior. Now, let's skip over this. Actually, no, this is right. So when I type in that search bar, nothing happens. But when I click the search button, or on the simulator, if you hit return, you get called with this delegate method for search bar search button clicked. And let's take a look at what we do here. The first thing we do is we say end editing. End editing tells the search bar to hide the keyboard. We're done with it. Then what it does is we've got two arrays actually that we're dealing with, right? So we've got our all names, and we've got filtered names. So what we're actually going to display in the list is the filtered names. By default, we want to show all the names, because when there's no search query, we want to show every name. You haven't searched yet. So back down here, when you do a search, first we remove all the objects in filtered names. We get the query. We get the text string that you just typed in. Now, here's the case where they haven't typed anything. If they haven't typed anything, you don't want to show nothing, because you want to show everything, right? So the empty string means don't search, show me all the results. So in this case, string length is 0. I want to add all the names into my filtered names. But what if the length of the string is greater than 0? What if they actually typed something? So here we're going to do the search ourselves. We're going to manually go through each of the strings, and we're going to see if it matches, and if it matches, we're going to put it in our filtered names array. So we start by looping through, using fast enumeration, through the all names list, and we call this range of string function on NSString, which takes a string. It's called on a string, and it takes a string. What it does is it looks for the query inside of name and returns to us a range. And a range is a location and a length. It's a structure that you get. If the length is greater than 0, it means it found a string, it found that match, so we're going to add it to our list. And if we get nothing in that list, if nothing comes out of that whole loop, then we're just going to show the string, no results found, and be done. And of course, then we reload our table so that it knows to display the results. So once again, let's do this. So if I type EV, it goes, it knows that I typed something. It's going to look for EV in all the names, narrow it down to Evan and Steve, and that's it. Of course, the table view functions are exactly what you've seen in the past. Number of rows is the number of items in filtered names, and the cell is in this case, we're not reusing, and we just set the name to the ones in the list. Yeah. Yeah. The question is, are there more sophisticated search filters to go through? There's actually some methods on NSArray that should help, I believe.
Clarify the question. Like what is he thinking about searching?
Well, so what are you thinking about searching? Yeah, I don't know. I mean, oftentimes, let's say you're getting data off a network, you would search the network. Right? You'd have the network do the search for large amounts of data. Yeah, it would depend on your case. I think in this case, it's more, just showing the fact that you can filter these results. If you have a better way for your set of data, probably better to do that.
It's app specific.
Yeah, it's really app specific. I thought there was some functions here that would help you. There's NS. What is that? I'm trying to remember. I'll try and think of it. There's email me actually afterwards. There's some way of doing. Oh God, what's it called? I don't remember.
In terms of sorting?
No, it's not the sorting. It's the. Anyway, it's used heavily in core data. Anyway, another thing I want to show you here is, okay, let's say you didn't want to wait till I hit return to do a search. You want to do a live search. There's other methods we can get at. So let me click on this. Let's look at the header for UI search bar. And there's a search bar text did change. So I'm going to take that, and I'm going to replace this whole thing here. We're going to call this a search bar. And what's going to happen now is as I type, we're actually going to refilter the results. So you get this live search going. What I don't want to do is hide the keyboard when this happens, because if every time I typed a letter, the keyboard went away, it'd be a pain in the butt. But so let's give it a try here. Again, all this stuff is in the search bar headers. So now as I type EVA, right, AL, they're all there. So any questions on searching? Any other questions on searching? Okay. And I'm still trying to think of what that class is. I know there's something that will help you. Okay. The question is, is the range contiguous that we got back in that search function? And the answer is yes. Yeah. So it's actually looking for a match of the string you gave it in the greater string. There's actually options you can have on it that say do case-insensitive search. I can't think of what else there are. But yeah, there's a few different options to that function. This sample code will be up on the website, so take a look and play around. So the next thing I want to talk about is notifications. So oftentimes in your application, you need to be told when something happens somewhere else. And there's a method. There's a way of doing this through a system called NS Notification Center, which I'll get into. Basically, what happens is you have a notification center that kind of sits global to your app, and you can create these other ones if you want specialized one. But generally, you use this NS Notification Center. and you can have several different observers that all ask to be notified by the notification center when something happens. And then when something happens, and I'll talk about what that looks like, the sender sends a notification to this notification center, and it's really just a string. And then the notification center goes ahead and tells all the observers that this one event happened. And then the observers, each one of them can go do something specific that they need to do. So, when do you want to use notifications? Well, if you have, oftentimes you've seen this implemented via delegate, right? When you want to, somebody hits a cancel button, some other object needs to be notified about that. The way we've been handling it so far is we have a delegate method, and you call that one observer to say, hey, somebody clicked my cancel button, and then they know to close it. Well, in this case, this is really useful when you know that there may be more than one observer, or you really don't want that one-to-one connection between the objects. It's much more loosely coupled than delegation, so you really don't know what the other object looks like or what they implement. And it's very flexible, very powerful, but sometimes it's just a little too blunt to be using as an instrument for letting others know about things. So delegation sometimes makes sense, sometimes notification makes sense. And we'll take a look at some of the ones that the system provides to give you an example. So to register for a notification, there's a method called addObserver, selector, name, and object. And selector selector is the standard selector stuff that you've seen in the past. But basically, if you want to listen to something, you tell the NS Notification Center that you want to listen, that here's your object. It should call this method when my foo notification happens. And my foo notification is just a string. So that's something to be aware of. Oftentimes you may misspell it, or sometimes it's better to use constants like the system provides for you. And there's an object that you can pass in that says, I want to know when a specific object posted a notification. If you left that object field blank, then you're asking the notification center to tell you when any object posted a specific notification. To receive a notification, so like I showed you here, you're actually passing in selectors. And the format for the received notifications is I'll show you the format first. So you actually get your callback here, your selector called, with the notification as a parameter. Inside that notification object, there's a few things you can get. You can get the name, which is the my foo happened. You can get the object, which is the object that sent the message. And you can get user info, which may or may not be populated with some data. Depends on what the object that's posting the notification wants to send. But user info is just a dictionary. So inside that dictionary, there may be specific information about what actually happened. And they're received on the same thread that they're posted on. So within the same within the same call, the notification gets posted, you're listening to it, you get called, and then it comes right back and continues to execute. And you have to unregister for notifications. So if you don't do this, you're going to continue to get called even though your object has gone away. Right? So it's important to do this in dealloc. There's a way to say, take me off of all notifications, or you can unregister for notifications one by one. And here's what it looks like. So in our dealloc call, we're actually going to call remove observer with self, and that tells the notification center that I don't want to hear about it anymore. Don't tell me when anything happens because I'm going away. And remember, you're going to crash if you don't do that. Yeah. The question is, does that mean the notification center does not retain the object? And yes, that's true. Yeah. So the question is, can the main thread not listen to its children threads? The answer is, I don't. You can register for a notification on a different thread, but you're going to get called on the thread where the notification was posted. So you're actually not asking threads to notify you. You're telling this. You're telling the centralized object that you're the contact point. So, yeah. 1 second. OK. So posting a notification. I've shown you how to listen, and I've shown you how to receive the notifications and how to unregister for them. But when you want to tell others that something happened, this is what you do. So again, we're going to use a constant instead of an actual NS string just to prevent errors and to provide in our header something that other objects can use as a constant. But here we go. So down here, something happens, and I want to tell the world. So I call NS notification center default center, post notification with the string of the notification, and I pass in myself, or the object that's posting the notification, and if I want, optionally, a user info that has some keys and values about what's happened. So UIKit uses this extensively. I'm going to show you an example that uses the actual UI search bar, the UI keyboard notifications. There's others, so memory warnings. A lot of the application delegate methods can also be listened to as notifications. Significant time change, so if somebody changed the date and time under you. And then the keyboard showing and hiding is what I'm going to show you today. So let's look at that. All right, well, if we go back to our same application here, and I run. So here's my table view. It scrolls fine, but when I pull the keyboard up, if I try to scroll, you'll see the stuff at the bottom is not visible. Well, the reason that's not visible is because when we created this table view, it's really the height of the phone, right? So when the keyboard came up, it's obscuring the bottom of the table. So what we want to do here is we want to find out when the keyboard comes up so that we can actually inset our table to hit the bottom of the top of the keyboard. So we're gonna shrink our table down, or we're actually gonna change the scroll view so that it can display above the keyboard. And the way we're going to do that is using these UI keyboard notifications, which I'll show you here. And we're going to do it in our view did load. So when my view loads, I want to ask the system to tell me when the keyboard comes up and when it disappears. So I'm going to do this. I'm going to say to notifications, NS notification center, center, add observer, and we're going to say self. So call me. The selector is, I actually have these methods already put together. Keyboard will show, and keyboard will hide. So selector is keyboard will show. Now the name, we're going to go to our docs here, and I believe it's UI keyboard did show notification. So let's copy that. And the object, well, I think we'll just do nil. And we're going to have another one for when the keyboard hides so that we can restore the height. We'll hide. We'll hide. And change the name down here. So now we are loading, and we're asking the system to tell us when things happen. And of course, in our dalloc, I already have it, but we're going to remove ourselves as observers from the notification center. Now down here, the actual functions that get called, so keyboard will hide and keyboard will show. Let's look at those. So in keyboard will show, we get the notification, and then we're actually going to use the user info key to know how far up we should move our scroll view. So I'm going to get the bounds of the keyboard with this UI keyboard bounds user info key, and we're going to get the center, right? So we'll know exactly where the keyboard is positioned on the screen. So here's a little math that basically calculates the frame of the keyboard. First, it takes the center and the bounds, and then it converts it to. It figures out our frame, and it figures out both with respect to the window. Okay, and then it intersects the two. You can look at this math in your spare time, but basically it intersects the two tables and figures out what's the intersection between our table view and our keyboard. So then when we do that, when we have that rectangle, we can actually call this set content inset on the table view, and tell it that it should actually scroll past the normal amount by a certain distance. In this case, we're going to, you'll notice, actually, let's look at UI edge insets make really quick. The format is a little different than CGRect that you're used to. Here it says top is first, then left, then bottom, then right. Don't ask me why, but that's the way it is. So top, left, bottom, right. So when we say UI edge insets make, we're going to say don't inset by anything on the top, don't inset by anything on the left, inset by the height of the intersection frame on the bottom, and then don't do anything on the right side. Then we tell the table view to move up the bottom of the scrolling area by whatever this height happens to be. I think it's about 216 pixels. And it tells it to set the scroll indicator by that amount as well. And then in our keyboard will hide, we set the insets back to 0 for both cases. So when I run and I type, actually, I don't even need to type. If I just scroll, now our scroll view goes to right above the keyboard, and so do the scroll bars on the side. Now, if I want to catch this notification, just as an example here, I'm going to put a breakpoint in keyboard will show, and we'll see exactly what's going to happen. So I'm going to debug. So now everything's fine. Nobody's called us yet. But the moment that I click in the UI search bar, by default, the system's going to show the keyboard for you. So here I click, and my debugger got called with keyboard will show. And there we are. So now that's when it goes through and says, take the user info from the notification, get the bounds. There's the bounds. Get the center, calculate the frames, figure out how much to move it, tell the table view to change its rectangles, and then now we have our insets properly set. So that's notifications. There's a whole slew of notifications you can find in the documentation. Like I said, the UI application posts a bunch. You should take a look at those. There's actually notifications for things like orientation changes. So if you're trying to do stuff with the accelerometer, you're trying to do something different in landscape view than you have in portrait view, you can actually ask the application to notify you for that stuff. So that's notifications. Again, so the notification stuff is really, it's kind of a system-wide notification system, or an application-wide, I should say. There are other ways to do this where you can actually ask an object to tell you when a certain value is changed. That's what I'm going to talk about here. Without what I'm about to talk about, with the NS notification case, if you wanted to be told when an object's value changed, you would need to add code to that object's setter to post a notification, and then it posts a notification, and then you need to go and listen to it, and you get called back. And it's a lot of code just for listening to one property change. So what I want to talk about is something called KVC and KVO, and we've actually already been introduced to some of this and some of the foundation for this, but now I'm going to show you some of the power behind it. You've been used to accessing properties on an object by using the dot syntax, so person.name, and you've also seen how to call the getters directly, so person name. But there's another way to get those values from an object, and that's using this KeyValue coding. So KeyValue coding basically says that you can ask a value for you can ask an object for a value by a string key, and here's an example of that. So using the same, that's actually wrong. That should have a @ symbol before it. And so should the one below, which it does. So you can ask the object for a value based on a string key. And the NS object's got a bunch of stuff under the hood that knows how to say, well, somebody's asking me for a value by key name. The first thing I'm going to do is see if there's a getter. And if there's a getter, it goes and it accesses it through that. And you've seen how to implement getters, right? You just call dash ID, and then the value, and then semicolon, and then you implement your function. But you can also set this way too. So you've seen how to do this, set name with a string, or with a value. You can say person.name equals value. And then there's this third way that I want to introduce you to today, which is using the set value for key. And again, the key is just the string version of the property that you're trying to set. So we're getting and setting values from an object based on a string. And there's something called KVC compliance. Now, KVC compliance, you may not know that you already knew how to do this, but you already know how to do this. Basically, if you're, oh, I'm not showing it here. If you're, let me add something to the slides here. Okay, if you're familiar with doing this, ns string name and implementing your, return name from there, and you're familiar with doing set name, then you already know how to make your your objects or your values KVC compliant. So basically, the key value coding in NS object will know how to access your values through these methods. Right. OK, so there's also, right, so I think I screwed up the slides earlier. But the second thing I want to talk about is key paths. So a key path allows you to get to a chain of values through a dot syntax in the key path. So let's take a look at, if I wanted to access the street of an address of a specific person, I can actually use these value for key paths to say, give me this path, the person.address.street, and it will return it. It'll actually, first it's going to ask, it's going to ask for the person, and it's going to return a person object. It's going to ask for the address object, and it's going to ask for the string object of the address object. And then similar to this, it actually does all that parsing for you. Now there's also, well, what happens, this is, what happens if you don't have a key defined? You can actually even do something then where if you ask a person for a name value, but you don't have a name value on that person, you have a first name and you have a last name, you can override this value for undefined key, and then you can automatically concatenate those two strings when somebody asks for name. So they don't have to ask for first name and then last name and then concatenate them themselves. You can do that for them. I'm going to show you a demo of that. OK. All right, so here I have a person object. OK, and that person object has a first name, a last name, an age as an integer, and a person who's mother. So it's a pointer to another person object. It also has a social security number, which is a private IVAR in that object. Then I have properties for first name, last name, and name. I have a property for age, and I have a property for mother. And I have an init call with social security number. So because the social security number is private, I don't want to provide accessors for it, so I'm not. But I'm going to show you how to get around that. So that's the header. Now we'll look at the object. So I have this. I'm going to synthesize first name and last name, which creates getters and setters for the first name and last name IVARs. Same for age and mother. I have this init with SSN function, which takes a social security number and assigns it privately to that person's social security number. I'm a good citizen, so I dealloc. I should also dealloc the social security number. Oops, I have to do that by hand. And then the other thing I wanted to show you here is that I've got this name property. It's a read-only property, but I don't have an IVAR associated with it. So synthesizing it's not going to do anything. So instead what I'm going to do is I'm going to concatenate the names for the caller. So it's a full name. It takes the first name and the last name, separates them by the space, and returns that as a name. And then I have this undefined key. Actually, let's leave this out for a second. I'll show you what happens if I leave that out. So we're going to run.
Should the SSN equals nil or self-dot?
No, because it's not a property.
Why are you just knowing?
Oh, right.
That isn't going to
That should be a release. Yeah. Thank you. I'm going to show you the nib here, too. All right, so what I've got here is I'm basically going to show you how to use the string as a means of accessing the variables, the values inside of an object. So I have this, call it like a little database app. I've got a fetch value where I'm going to type in the key that I want. It's going to display as a label here the value, and then ignore the change to. We'll actually look at that a little bit later. So first things first, let's run. Actually, I should show you this as well, which is in my view controller. What I've done is I've created two people, Evan Dahl, who's 36 years old, created his mom, she's 63, and I've set Betty Boop as Evan's mother. I've got two methods here, fetch value and change value. So in the nib, this, when I type into here, this is when I'm done typing, there's this did end on exit, which I'm going to send an action to my my view controller to call fetch value, and the change to, when I finish typing in there, it's going to go and tell the view controller to call the change value method. And what they do here is in fetch value, I'm actually going to get the string that I typed in as a key path. I'm going to get the value for that key path, and then I'm going to output whatever comes back as in the output label. And in the change value, I'm going to get the key field. So the key field is the same as the fetch value. I'm going to set the new text. I'm going to get the new text that I want to set, and then I'm going to set the value that I type in the change to as the key for the person that I'm dealing with. So let's give that a run. All right, so our person is Evan. If I type in his first, if I ask for first, oh, I should go to my simulator. If I type in first name, it's going to return Evan. If I type in last name, it's going to return Dahl. And if I type in name, it's going to return Evan Dahl. Another thing is, if I type in, these are strings, that's easy. If I type in age, which is an integer, it actually creates it to an NS number. He's not 36. It converts it to an NS number, which is easily convertible to a string, and the text fields know how to deal with. So there's one thing here. Now, to talk about key paths, if I was to ask for, Evan's mother's name, I can use the dot syntax as a way of getting first to the to Evan, then to his mother, and then to her name. This is toned down, so let's just see what it was before. OK, so mother.age, that all comes back, and mother.social security. Actually, this is the other one I wanted to show you. So, OK, so you remember how I didn't have a property for SSN, right? And I don't have any getters, and I don't have any setters. One of the things that the KeyValue coding will do is it'll automatically, first, if it doesn't find getters and setters, is going to look for IVARs that match the name. So without having created any setters and getters, and without having set up any properties, I can just type in SSN, and it goes straight to the IVAR. So it's very powerful. It could get you in trouble, especially in this case. But it works. So now let's try the change to. Okay, so if I take, first name. Another point I want to make on this is if we didn't do it this way, right? If we didn't implement this code such that fetch value is looking by keys, in order to do this, I would have to have a big if statement. If string is equal to name, then get the name and return it. And set the text field. If string is equal to last name, then do that. If string is equal to age, etc. All right, so this is one easy way at just getting at that. Now let's look at the change to. So once again, we're going to take the key in the first text field as the key for the object that we want to look at. we're going to take the value in the second text field, and we're going to set that as the value on the person object. So if I say, I want to set Evan's first name to Schmeven, and I want to change his last name to Schmo. Then we asked for his name, and it's now Schmeven Schmal. So that's key value observing, right? So we did all this. We got to all these variables inside of these objects without ever having to write any of these if statements to do that. And we actually just accessed them all by string. So that's key value coding. That's how you set up your objects so that you can access the variables directly. Now, what if you want to know when a value changes? Okay? So you've got something, in this case, you've got something completely disjointed. You've got another object that wants to listen to make sure that the social security number doesn't change, right? Or wants to be notified when Evan's first name changes so that it can do something. Well, the way to do it today that you know about is you actually have to add code to your person class that would either add a delegate, so you need a delegate property, and then the delegate can get called with, first name did change. Or you would need to post a notification, right? So in your set value or your set name, you'd have to say NS notification center, post notification named, name changed, blah, 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 blah. Right? There's an easier way, and that's by using key value observing. And this is super powerful. I use this everywhere. I abuse it maybe. But it allows you to ask an object to let you know when a certain value has changed. And it does that as long as your variables are KVC compliant. The NS object already knows how to tell listening objects about something that's changed. And you don't need to change your object to make this work. So here's how you do that. So to listen for changes, you have this, the object that wants to listen calls on the object that it wants to listen to, calls addObserver with self. For key path, so if I could put in the string for name. Options, there's a set of options. I wouldn't worry about those for now. And context. So if you want to pass in just a random object that you want to get back when that gets called, so you can use it as a context. And to stop listening for changes, you use remove observer for key path. Unlike NS Notification Center, you can't just say remove observer on everything. You still need to remove them one by one for the key paths. So when you receive a notification, you override this observe value for key path. And this is in every one of your objects that's a listener. You implement this, and then you get called. You can check the context, or if you don't have a context, you can check the string. You can say if key path is equal to string name, then go and do something. Otherwise, call super. So let me show you how that works. Well, what I want to do here is I want to make sure that nobody changes Evan's social security number, or else we have a problem. So let's go into our app delegate. Now this is not our view controller. It's not our person object. This is a completely third-party object. And what I've done here is, well, let's go up here. In our application did finish launching, I'm going to ask the view controller to tell us when person.social security number changes. And it's going to call us back with observe value for key path. I don't need to pass a selector because all of my observation is going to happen through this function. And then what I'm going to do is, you notice I'm passing the context as view controller, and that's just to make it a quicker check. So when I get called for observe, if I have several different observations, I would have different contexts, each one specifying a certain thing that happened. So in this case, I'm going to throw an alert. So when somebody changes the person.social security number, security warning, someone is hacking the system, contact the authorities, call 911. So that's that. That's all we have to do for observation. I don't have to change anything in the view controller. I don't have to change anything on the person object. I'm just going to run. So fetch value, social security number, That's Evan's social security number, so bank accounts. And we're going to change that to 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. Now, that's actually going to make the change. I'm not preventing the change. But when I hit return, the app delegate receives the notification, it throws an alert, and you do whatever you want. The takeaway from this, of course, is that you didn't have to change the object. This third object just says, tell me when this object's value has changed, and it automatically works for you. Again, you need to make sure that your values are KeyValue compliant, so you use the proper getters and setters that we've been talking about the whole term, and you're good to go. Yeah. Right. So the question is, what if you don't have any getters and setters in your instance value variable? The answer is yes. It'll go automatically to the IVAR, and it will set or get the IVAR directly.
But if you have some that are not KVC compliant.
Okay. So what happens if you try to access an instance variable that is not KVC compliant? Or even better, what happens if you try to access a key that's not defined in your object? Well, this is where you use the value for key and value for undefined key, and you can do whatever you want. So, all right, so let's take a look at this. I'm going to actually override this value for undefined key, and I'm going to say, whenever you try to access a key on my person object that I don't know, I can't deal with, instead of throwing an exception, which is what would happen normally, let's actually run that really quick. So if I try to, I ask for, let's say, middle name. That should have thrown an exception. Why didn't that work? Okay, so that still works. Middle name. That's not doing anything. Oh, WebKit's throwing it away. Oh wait, that's weird.
The exception is being thrown, but
Yeah. Okay, so actually our exception's thrown. I don't know why it's not getting caught in the debugger. You see here, value for undefined key. This class is not coding compliant for the key middle name. Well, I want to catch it, and I basically want to fail gracefully whenever you ask for any keys. Maybe, I don't know, you've got an object that dynamically adds and removes keys, and Evan will talk about that another day. But I'm going to override this value for undefined key, and I'm just going to return a string. Okay, the string is going to say, this person doesn't have a whatever that key is. So when I run it, and I type middle name, Evan doesn't have a middle name. Okay, so the answer is whenever you try to access something that doesn't exist for a given object, it's always going to go straight to that value for undefined key. Yeah.
I guess what I meant was like, you said that it would basically create its own setter and getter if you didn't have one. But what if you have one that isn't correctly named, basically?
Wait, what if you have an instance variable that's not currently named?
An instance variable, but you have,
right.
You have setters and getters, but they're not correctly named, basically.
So if you have an instance variable that you're trying to access, and the setters and getters are not correctly named, so they're not named according to KVC compliance, then it's not going to be able to access them.
It's not going to make up its own stuff?
No, it's not going to. It's not creating these setters and getters. The only thing that creates the setters and getters for you are the synthesize. When you do synthesize for a property, that generates setters and getters. But if you try to use the key value stuff to get a value, it doesn't create the setters and getters. It actually does another lookup table. There's like a lookup table that happens in Objective-C under the hood, and then it's going to go and try and find them for you.
it would end up falling back to the direct IVAR access if you had some
Right.
named in.
Right, okay, so yeah, if you tried to access that, if you have an instance variable, you didn't name your setters and getters properly, and you still said value for key with the proper spelling of your instance variable, it's going to go straight to the instance variable. Does that make sense?
Yeah, so I guess the takeaway is that if you've got code in your getter or setter that you care about having execute, and you're planning on accessing it via KeyValue Coding, you need to make sure that your getter and setter are are named in such a way that KeyValue Coding knows how to get to it in that standard, like either just the name of the property or the set and then uppercase. If you have some alternate naming for your getters and setters, then KeyValue Coding won't know to go through those methods. So.
That answer? Okay. Are there any questions? Other questions about this stuff? It's really powerful. There's a ton of, you'll find it useful in a lot of different places. It's easy to get tripped up if you're spelling your properties wrong. Maybe you're spelling your setters and getters wrong. But yeah. Okay. You don't need this for Presence 4. It's just a nice little bonus for notifications, discussing notifications. Right. And actually, just to take this a little further, and I'm not going to show you, I'm not going to really get into detail on it. There's something called key value bindings that exists on Mac OS X that doesn't exist on the phone, where you can actually say that I automatically want, let's say, this control to be bound to this object's value. So it does all the controller code for you, essentially. You can say, I automatically want this slider to be bound to this object's volume value, for example. And then when the view first comes up, it asks the volume value for its current value, sets itself up properly, and then whenever you move that slider, it automatically sets the volume value on the object that you're bound to. And there's no glue code that you have to write at all. It's all done for you under the hood. So again, not on the phone, but very useful, Mac OS X. If you want more information, there's actually I was showing you how you use value for key and set value for key to get to the getters and setters. There's a whole bunch of other stuff that you can do, like you can say count of children or whatever your instance variable is. There's a bunch of different things that you can override, and as long as you follow the standard KVC compliance format, you get all this stuff for free. And this is where you can find out about each of those. So that's it. I want to show you a demo of Presence 4, which is due next week. This takes you a little further on the Twitter channel, Twitter app. So let's pull it up. Without showing you the code, I'm going to run it. All right, so this we've seen before. As you click on the different people, it shows you the Twitter statuses that they've posted in the past. Well, you have the compose already. What we've added here now is you can actually get more detail on a person. So when I click on a person, there's the address book entry for that person. And this is using the address book APIs that you saw last week. On Monday. You can create a new contact, which would automatically add it to the address book on your device. You can add it to an existing contact. What else? When you click that, no. Is that it?
Public and search.
Oh, public. Right. So actually, let's look at search. So if I search for CS193P, right? So now here we have search. Not sure under the hood what's happening here. I believe it's searching on the server, right?
We've added some files. There's a new method to Twitter helper.
OK, so Evan's telling me there's a new method on Twitter helper that will help you do the search. And then here's the public stuff. Whoa, there's a bug.
He's got a really big image.
That's kind of interesting. So what's this? This is when you...
These are the people who, in real time, who've most recently Twittered.
Oh, wow, cool. As people are posting, they're showing up on my... That's pretty cool. Anyway, so this is Presence 4. That's crazy. Yeah, scale your images, so if you get this guy show up. Anyway, so this is Presence 4. Again, the takeaway here is the search stuff and the address book.
And then nesting in the tab bar controller.
Right, and then, yeah, the nesting in the tab bar. Oh, yeah, actually, let me show you that. So, so far, I believe all you've done are navigation controller-based applications. One thing to note, which we've actually covered before, but I want to just give you a diagram to show you what it looks like, is, well, those are the features. But yeah, so the thing here is instead of having, when you create something that has navigation bars and tab bars at the same time, what you want to do is you want to nest your navigation bars inside the tab bars. So the structure is actually, your tab bar controller is the root for your project, is the root view controller. It will own 3 different view controllers, 2 of them which are navigation controllers, which of course own their own view controllers. And I believe the search one is just a straight view controller. So that's the structure you want to go for. If you try to do something different, like having one master navigation controller with a tab bar inside, I guarantee you're going to run into problems. So go that route. That's done. And then just one last little takeaway here, which is if you want to add frameworks to your application, which you're going to need to for this address book stuff, I just want to show you how to do that. By default, your app doesn't link against address book, and there's all kinds of different frameworks that you may want to link against in the future, so you can browse that way. But there's in your target, in Xcode, if you get info on your target, you can actually add all the frameworks there, and it'll list them. All the ones that are available to it will be listed. So let me show you that really quick in Xcode. So this is the Presence 4 assignment. If I go to, here's my project. If I go to Targets, click on Presence, and I say Get Info, which was Command I. There's also that Info button. All right. Then I can, down at the bottom here, there's a little plus button. When I click on that, there are all of the frameworks available to me. You may want to, filter by frameworks. You can add any one of those to your application. Be careful. I think this is including the Mac frameworks. So yeah, but for now, address book and address book UI are right there. So that's it. That's it for today. Are there any questions about any of this stuff before we head out? Presence 4, KVO, KVC, KVM, KVB. No? All right, we're done. Thank you.
For more, please visit us at stanford.edu.